So, friends, welcome to this lecture series of geomorphology, and today we will continue with this glacial geomorphology. So, if you remember, in the last class we are talking something about the glacial formation and the contribution of glacier to our freshwater budget as well as this water cycle of this globe. And we found generally there are two types of glaciers we can classify based on either it is a valley glacier, it is composed of or it is ice mass which is confined within the valley, and another is your ice sheet which is about 2.5 kilometer average thickness, and its middle part it is more thick and it is the accumulation zone and it is spreading outward from this center, and that is why this aerial view of this glacier movement is radial as compared to this valley glacier. And similarly, this valley glacier during movement it mix with the other glaciers, and it is due to its easily deformable part, easily deformable rheology. So, this valley glaciers and this main trunk glacier they mix or they coalescence at the same level, but its identity of this valley the identity of this tributary glacier they remain identical or distinguished for long distance and later they mix up. Similarly, there are two zones of movements. During movement there are two zones of this valley glacier, one is the zone of compression, another is zone of extension, and zone of compression it movement is less and mostly it is abrasion, its characteristic erosional process, and then once we are coming to the extensional flow it is extended and there are crevasses are developed, and finally the glacier moves with different velocity at different points. And today we will talk about glaciology. Glaciology means it is the scientific study of all ice, not just valley glacier, not just the ice sheet, it is all ice, all form of the ice crystals, that is high cloud, hail, snow, frozen lake, river, ocean water and glacial ice. And this also includes this frozen ammonia as well as methane, mainly it is found in Saturn, Uranus and Jupiter. So, that means glaciology is a broad term, that means irrespective of its glacial form, irrespective of its composition, it covers all parts of this glacier system. And this H2O ice are probably these materials of many of these moons of these outer planets. So, that means once we say glaciers or glaciology, that means we include all those things. Now, how this glacier ice is formed? Generally, there are few sequence of events that this it is regular sequence is there. This follows. The first is the fresh snow is full of entrapped air and may have bulk specific gravity about lower than 0.1. So, it is so light that it can be blown for few distance, it is certain distance by air. Then snowflakes, it is readily sublime, sublime means it is vaporized from this solid state without melting. So, aging snowflakes lose their firni or lose their frilly margins and becomes more globular. Meltwater often freeze onto snowflakes nuclei. So, again also tends to increase the size of this ice granule. So, that means if you analyze these figures you can easily understand how these processes are involved, what are their changes occurs starting from this snowflakes to glacier ice. So, in the other way it can be said it is the type of metamorphism that occurs which transforms the snowflakes to glacier ice. So, if you see this left hand side figure here, you see these are this ice crystal, the shape of this ice crystal, that means crystal structure of this snowflakes. You see it is looking like a very nice flower. So, snowflakes all fall and accumulate. So, the next stoppage, once we are accumulating snowflakes one after another. So, you see such delicate structure, crystal structure as they are very nicely developed crystal structure, but once we are keeping them together. So, this crystal structure deforms. So, that means as ice compacts, flakes undergo pressure solution. Then continual compaction produces packed granular slough, that is called firn. So, now you see once we are going more or accumulating more and more snow there, gradually we are creating some pressure solution through which the crystal structure we are deforming, and more we are producing more or more granular we are making it, and finally, we are converting it to firn. Pressure solution of firn produces glacial ice with trapped air that produces blue color, that is very important here. Glacier ice you might have seen from Discovery or any photographs from glaciologist and in the internet, it is blue color. Why this blue color appearance? This is due to the entrapped air. So, more air is entrapped, more blue appearance of this glaciers. And the older ice is coarser grained. That means, starting from individual snowflakes, you are coming to coarse grained ice which is granular. So, this transformation, this deformation of snowflakes crystal, snow crystal, if you see here, the snowflake crystals gradually deforming and finally, after 10 years it average it is creating glacier ice. So, here snowflake, then deformation, granular appearance, it is called firn, then it is creating glacier ice and this movement of glacier ice is there. So, that means, here at this initial time when there is snowflakes, there is 90% porosity, and that means the pore space it is occupied by air. So, with granular ice it is porosity decreased to 50%. Then once it is firn it is 20%. So, like glacier ice it is 0% except some water bubbles are there. So, that means gradually this transformation it is called the metamorphism of snowflakes to ice sheet. If snowflakes or the snow it has survived a summer melting season, it is called firn. It is in German or in French it is called Neve. Firn or Neve is an intermediate step in the conversion of snow to glacier ice with a bulk specific gravity between 0.5 to 0.8. So, that means, we have snowflakes here, we have glacier ice here. In between this firn, it is the transition. So, it is a granular and loose unless it is formed a crust. So, that it will remain here granular and it is loose like loose sand. So, it will convert until unless it is forming a crust. So, it remains granular. It represents the net positive balance between winter accumulation and summer loss. So, as successive annual layers accumulate, the deep firn is compacted and individual ice grains freeze together. So, we are creating a glacier ice sheet there. So, this transformation process from snowflakes to glacier ice, it takes about 10 years or so. So, that means, it is the initial stage 10 year, but if you are talking about these Antarctic ice sheets, you are talking this permanent ice caps. So, that means, it is taken, if you see here, it is about, if you are getting 250 meter of ice sheet, it is taking 10,000 years. If you are getting here 2000 meter ice sheet, that it is getting about 1,30,000 years. So, that means, if we date those ice sheets at the core of this ice sheet, then we can see how much time it has taken to form this much thickness of the ice sheet. So, the Antarctic ice sheet, the Greenland, the Iceland ice sheets, they are very old as compared to this ice sheets or this ice of this the glacier of this valley glacier, this permanent ice caps. So, by definition, when the grains are frozen together, so that the mass is impermeable to air, Firn becomes glacier ice. The bulk specific gravity is usually 0.8 by this stage of consolidation. Glacier ice is a polycrystalline mass that includes a variable amount of entrapped air as well as dust and rock fragments that have fallen, washed or has been blown into the ice surface, and rock that has been eroded from beneath these glaciers. So, that means here we have a material which is mixed with mixed with glacier, mixed with dust, rock fragments, that rock fragment below from these glaciers or the ice sheet, or it is fallen side from this enclosed mountain system, enclosed valley. So, all together if you say, that means glacier. Glacier is a mixture of all those things, that means the whole system that moves from one place to another. The bulk specific gravity of glacier ice ranges from 0.8 to 0.9, close to the specific gravity of pure gas free ice is about to 0.916. So, that means this 0.916 is the pure the specific gravity of this pure gas free ice, but still it is lighter than water. So, that it is floating on the water. You might have seen in this discoveries on the TVs or in real life, there are masses of ice that are floating on water. This is due to this low specific gravity than water. So, now whatever this ice, that means maybe it is valley glacier, it may be this glacier which is the sheet form, then we have to classify it. This classification is based on certain schemes. The first classification is a descriptive based classification. What is this descriptive based classification? One is called Cirque glacier. Cirque glacier, if you see, it is confined in Cirque above the valley. If you see here, these are these cirques, that means it is confined within that valley, that is isolated, that is Cirque glacier. Then valley glaciers, that means here this is the valley glacier, this is confined within that valley. Here Cirque glacier, it is isolated, but it is valley glacier, that is moving within the valley, confined by these valley walls two sides. Then ice sheet, that we know in high latitudes and like Antarctica, Greenland, we have ice sheets average of 2 kilometer or 2.5 kilometers thick. So, this classification is descriptive based. Then second classification is based on this process, or it is called process based classification. What is the different processes involved? One is called active glacier. Active glacier means the glacier is moving on movement, active movement. So, for example, here it is glacier is moving, active glacier. Then passive, a glacier with sluggish movement, where both accumulation and ablation are minimal. Sluggish, very slow movement, that is, or that means it is not detectable for a small time period. So, that is called passive glacier. Then dead glacier, static, may be due to arrest by topography or by less weight or so. If you see here, this is a dead glacier, that means if you see here, this is a depressed part and it is the elevated part. So, that means it is bounded by this topography. So, that means it is dead glacier until unless more accumulation takes place here, or until unless it is supplied more ice or more glacier ice is supplied here, it cannot move in this direction. So, it is topographically arrested. So, that is called dead glacier. So, based on this process, either it is moving or it is moving very slow process, or slow movement is there, or it is not at all moving. So, based on that, this classification is there. Then another scheme of classification is called thermal classification scheme. Thermal classification, that means based on this temperature. So, though we know the glacial system, it is a low temperature phenomenon, it is very minus, it is temperature region minus degree Celsius, but still based on the temperature we classify the glaciers into temperate glacier. template glacier means temperate glacier is at this melting temperature throughout this mass, but surface freezing occurs in winter. So, that means it is always melting, it is always providing water, its perennial rivers are there. So, though this temperature is of melting is throughout the year, but surface freezing occurs in winter. So, that means except winter all through this year this glacier is in the melting form. So, that is called temperate glacier. Then polar glacier, if you see polar glacier is again divided into subpolar and high polar. That means high polar means at this exactly at the pole or near to the pole, and subpolar means somehow away from this pole. Now, if you see here thermal classification glacier is called temperate glacier, warm ice throughout, upper active layer is thick, meltwater percolates and freezes, percolation maintains ice at pressure melting point, deeper ice colder than shallower ice, heat from below cannot be conducted melt at the base. Then polar glacier, cold ice is the inner layer, thin active layer, thick fin accumulation zone, high pressure metamorphism only, frozen to bedrock unless thick enough for basal melting. So, these are the difference between this temperate glacier and polar glacier. Now, here there is differences between this polar glacier and this temperate glacier is also given. If you see here these figures, this line orange color, it is the summer surface temperature. Now, if you see here this is temperate glacier and it is polar glacier. This line that is the summer surface temperature, if you see the summer surface temperature is starting from near about it is 8 degree or 7 degree and it is gradually decreasing. But here in the polar glacier the surface temperature lies around minus 15 degree Celsius. But similarly, winter surface temperature for this polar glacier is about minus 25 degree, but here it is about to minus 15 degree. Similarly, yearly temperature here if you see yearly temperature polar glacier it is varies from minus 25 to here minus 10, but here this temperature it remains constant, that means near about minus 2 degree or so. Similarly, pressure melting point it is starting from 0 about minus 2 degree, here it is starting from 0 to minus 2 degree or so. So, this pressure melting point remains same throughout, and here if you see 0 degree Celsius or normal freezing and melting point, these are these lines, this is dotted line, this is 0 degree. Now, if you compare these two, the temperature at the base is higher. I am talking about this temperature, this is temperate glacier. The temperature at the base is higher than pressure melting point. So, melting will occur and this allows the basal sliding. So, here the temperature at the base is well below the pressure melting points. So, melting at the base is no basal sliding. So, that means it is less basal sliding here, here more basal sliding is here. Similarly, if you see here as it is basal sliding, that means it melts. So, there is a water layer at the base. So, once it remains the water layer at the base, so basal sliding becomes easier. So, that this movement or the rate of movement will be more here. If you see here the rate of movement it is more as compared to this polar glaciers. So, polar glacier it moves at a slower rate as compared to temperate glacier. Movement of glacier results erosion of bedrock, transportation of rocks and fragments and deposition of these transported materials which changes the topography. So, there will be both erosional topographical change as well as depositional topographical change. So, erosion, transportation and deposition that occurs in the by this glacier, like other geomorphic agents like water, like this wind, they also erode and transport and deposit material. Similarly, this glacier also erodes, transports and deposits material, but the difference is that here glacier erosion is more deeper as compared to water or wind erosion. That means, glacier can erode up to the deeper level as compared to other geomorphic agents. Though it moves very slowly, but erodes very deeply as compared to other geomorphic agents. So, this is the difference between these other geomorphic agents and glacier. So, results in polished rock surface. Now, you see here at the base of this glacier, basal sliding causes scoring, that means it scores this rock at the base, and grinding, that means a huge mass which is transporting or huge mass below the bedrock and huge mass of ice in between. If rock fragments are there, they are crushed. So, that means its grinding is there, crushing is there. Erosion is proportional to the thickness of the glacier. That means, if the glacier is more thick, it will erode more, because more pressure is there at the base. So, more deeper level of erosion will be there. So, that means glacial erosion, it is proportional to its thickness. Glacier has the rock frozen into the base, increase the amount of erosion. Results is fine rock powder, that is called rock floor. Now, if you see here, this is the glacier, the thickness of this glacier ice, this fine grained, they are the rock floors, because they are crossing, grinding are there. So, rock floors are generated. So, and result in polished rock surface, scrubbed clean of soil and vegetation. So, if you see here, these rocks dragged over the bedrock can produce glacial striations. Glacial striation means, if you see here, these are the linear structures, lineations, these are the glacial striations. That means, it indicates the glacier movement on bedrock. Now, which direction the glacial has moved? Either, for example, if you see, we can say either in this way or in this way. So, by looking this type of steps, this type of structures, we can say which direction the glacier has moved. Now, if you see these steps, they are opening in these directions, and here, for example, here you can say it is a speed breaker, it is there. Similarly, here is a speed breaker. That means, if you take this cross section of this part, it will look like this. So, that means, this way the glacier has moved, this way the glacier has moved in this particular photograph. So, by looking this type of structures on the rock surface or the bedrock, you can say which direction the glacier has moved. That also, it is important to reconstruct the paleogeographical history or the paleoclimatic history by looking this type of structure and establishing the glacier movement. Now, the particular type of glacial erosion, that is called plucking or quarrying. So, what is plucking? It is similar to frost wedging. You might be remembering about this frost wedging when we are talking about weathering and erosion, especially the physical weathering by frost wedging. If there are fractures, water is freezed there, and once the water freezes, its specific volume increases, so that it produces cracks, and these cracks with time becomes wider and wider, and finally rocks are eroded apart or broken apart. So, this is called frost wedging. So, frost wedging is the melt water penetrates into the bedrock cracks and freezes, bringing angular blocks to rock of loose rocks. These blocks may be incorporated into this ice, producing boulders known as glacial erratics, which may be transported long distance. Glacial erratic is a very peculiar type of rock, which is not related to any rock in the surroundings. So, these are the foreign rock particles. So, it can transport it to up to hundreds of kilometers. There are number of glacial environment evidences in this Gondwana time. If you go to any Gondwana environment, the peninsular India, so you will find there are number of boulders lying here and there, which is not related to any types of rock in the surrounding. So, this is called glacial erratics. That means, they were transported by the glacier from hundreds of kilometers away, and due to this melting of the glacier, they are remaining there. This is called glacial erratics. So, plucking, if you see here, that if you remember our last class, we are talking something about this compressional flow and extensional flow. Here this is the glacier movement directions, and we have latches of bedrock exposure, and here there will be compression, and due to compression there will be erosion, there will be abrasion. So, abrasion or polishing, and mostly the glacial striations, they are very well developed at this part. And once the glacier crosses this barrier here, this side it is representing the compressional flow, and due to this compressional flow you will find these pluckings. That means, pieces of rock, they are plucked away from this bedrock, and it is remain at the base of this glacier. So, this type of removal of this rock from this rock mass or this parent rock or the bedrock, that is called glacial plucking. So, this is a photograph of frost wedging, then it is glacial plucking, and this is erratics. So, these boulders, suppose for example, these boulders, if they are transported by this glaciers of long distance and they are deposited in some part which is not anywhere related to this surrounding rock, that is called glacial erratics. Then another type of erosion, that is called abrasion, that we have discussed here. The abrasion, this side it is the abrasion or polishing of these rocks. So, abrasion is the rock fragments carried by ice function as a sand, that means behaves as a sandpaper that coats the surface over which the ice moves. The process produces rock floor, very fine particles of pulverized rock, that is striations, that is long grooves and scratches in the bedrock, and glacial polish, that is very smooth surface produced by fine abrasion of bedrock by rock floor. So, if you see these are the glacial striations, they are very prominent in the bedrock, particularly if it is a sedimentary rock, it will be very deeply scored, and it can in Indian context, if you go to any Gondwanan terrain like in Maharashtra, in Jharkhand or in Bihar, or wherever you go to this any Gondwana terrain, you will find this type of glacial scores. Based on this glacier core, based on the movement, the paleogeography is restructured, or paleogeographical region where this glacier movement was there, where glacial was forming. So, those places can be identified. Although abrasion models depends critically on whether clasts are treated as dependent or independent of subglacial water pressure, it appears that abrasion is favored in situations where effective basal pressure are greater than 1 megapascal and where there are low sliding velocities. So, if you see, if we have low sliding velocity, again low sliding velocity means we have low water pressure inside in this bed, in the interface of this glacier and bedrock. So, that means we are talking something about these polar glaciers. So, that means polar glacier, they erode more deeply as compared to valley glaciers. So, now you here these glaciers, so that means this abrasion is more effective, it is pressure which is greater than 1 megapascal. And this bulldozing action means simply, if you see here a bulldozer which is removing this debris, this from one direction to one place to another. Similarly, this glacier, it is behave as a bulldozer here, and this rock mass, if you see here, these are this rock mass that is falling here. So, that means this removal of this rock mass or transportation of the rock mass from one place to another, this mass transport is due to this bulldozing action of this glacier. Then geomorphic changes that created by glacier. The land smoothed and rounded from this glacial abrasion produces a flattened topography with rounded hills. Here, if you see here, we have rounded hills with flattened topography. Similarly, if you see, you have smooth hills and there is a flattened topography. Erosion strips soil and sediments away to exposed bedrock in producing ice cored plain. These are the ice cored plain, these are scorings, you can see this direction of they are the linear strips. So, this ice core surface, and if you see here, there the valley, the glacier was moving and the whole system was glaciated valley. If you see, drainage system is peculiar, that is called deranged drainage pattern, we will talk later. So, this glacier that strips this bedrock and finally, it is forming the bedrock topography, which is of a different kind, which is peculiar with the compared to other type of erosional systems. So, I think we should stop it here and we will meet in the next class to discuss further about this glacial system. Thank you.